We're in Algebra II at 9.7a now, and we're going to find how many x-intercepts of a vertical parabola with the discriminant. If you haven't seen the previous 14 videos, you might become lost or confused, and there's links to them in this description. You can just click on them. The x-coordinates of the points where a graph crosses the x-axis are its x-intercepts. That's where the points have y equals 0. So here we have, for the function of x equals ax squared plus bx plus c, you can see that this is a parabola opening downward, and the x-intercepts are right there on the x-axis. See, there's two of them there, okay? Now, if you remember from a few videos back, we've got our quadratic formula, and this section underneath the radical sign here is called the discriminant, this b squared minus 4ac. So remember, the terms under the radical sign are called the discriminant, and the discriminant tells us how many real number solutions the equation 0 equals ax squared plus bx plus c has. So it shows us also how many x-intercepts there are. So we can use that discriminant, okay? Now, let's compare these three graphs, okay? This one has the discriminant is greater than 0. So there's going to be 2 real solutions and 2 x-intercepts. This one has it so the discriminant is equal to 0. See, this one was greater than, this one's equal to 0. So there's only 1 real solution, and it's got 1 x-intercept. This one has the discriminant less than 0, so it would be a negative number, wouldn't it? It's less than 0. It has no real solutions and no x-intercepts. See that? It's not even touching the x-axis. All right? So if the discriminant is positive, the parabola will have 2 x-intercepts if it's greater than 0. If the discriminant is 0, the parabola will have 1 x-intercept, and it'll be the vertex of the parabola. If the discriminant is negative, the graph will have no x-intercepts. So we can find the discriminant and use it to find the number of x-intercepts of a graph of a quadratic function. So here's our quadratic formula. Here's our discriminant underneath the radical sign here. It's right here, b squared minus 4ac. Here's that standard form of a quadratic function. And we've got the function of x equals 2x squared plus 3x minus 5. You can see where the a, b, and c values are. A equals 2, b equals 3, and c equals a negative 5. When we substitute these values into the discriminant, we've got b squared minus 4ac as our discriminant. That means we have 3 squared minus 4 times 2 times negative 5. This 2 times negative 5 is a negative 10. Now we've got a 9, because 3 squared is 9, minus a negative 40. And if we have a subtraction of a negative number, we add it, right? We add the opposite. So now we've got 9 plus 40, so we've got a 49. And our discriminant is a 49. That's a positive number. So the parabola has 2 x-intercepts. Check out this one. Look, there's no b value, so b is a 0. We've got the function of x equals negative 3x squared minus 1. We've got an a value and a c value. So our b value is 0. So we got 0 squared minus our 4 from our discriminant times our negative 3a value times our negative 1c value. Negative 3 times negative 1 is a positive 3. We get 0 squared. That's a 0, isn't it? So we have 0 minus 4 times 3. So it's 0 minus 12. So that's going to give us a negative 12. So now our discriminant is negative, so the graph has no x-intercepts. Check out this one. Now we've got the function of x equals 9x squared plus 6 plus 1. We substitute our values from this equation into the discriminant. We get 6 squared for b squared minus 4 times 9 times 1. 9 times 1 is 9. 6 squared is 36. We have 36 minus 36. That's going to equal a 0. So because our discriminant is 0, the parabola will have one x-intercept, and it'll be the vertex of the parabola, just like this one. See? It hits the x-axis at one point. Okay? Now, our next video, we're going to find x-intercepts using the quadratic formula. We're going to find the actual points, okay? And I'll have any previous videos that can help you in this description, and I'll add this video to the Algebra II playlist. All right? I hope this made sense. It was pretty straightforward, and you just substitute in the values into the discriminant, and you should be okay. All right? This was important. You might want to have written that down in your notes, okay? Because that'll help you. All right, I'll see you next video, and let's see how we can do this. Bye.